So now that you have got your basics, which is to know how to work with the lines, these are typical exam questions that you are supposed to expect to have in your simplification. This is a June exam that we are given from the question paper of June 2016, which was from the Gauteng province. We are going to consider question number 1, which was on the analytical geometry on this paper 2. So we are given question number 1. In the diagram below, we are given the point K, the point P, which is all right, this side here, the point P, the point T. These are vertices of triangle KTP, okay? A and B are points on the y-axis. Okay, where is A and where is B? These are points that on the y-axis. There's a point A here. There's a point B. These are the y-intercepts, all right? A being the y-intercept of line KT, and B being the y-intercept of the line K to P or line BD. I don't know the way that you're going to consider this. All right. So this is what you're given, and you're given just points C and D on the x-axis. The point C and D on the x-axis, which is the x-intercept of line TP, and D, the x-intercept of line KP. So this is what we have, and we've got the angle beta, the angle alpha, and the angle theta, which is at T. So with this information that we are given, the first part of our question was to consider 1.1 was to calculate the length of KT. Leave the answer in the simplest said form. The answer must be in said form. All right, so this is the length of a line that you're considering. We are going to need the 2 points which lie on that line, K and T. So this is K and T. These are the 2 points that we consider. When given 2 points, we can actually calculate the length of a line. All right, so as we know that the length of a line is taken from our formula, that is the difference that we have x2 minus x1 squared plus y2 minus y1 squared. So this is just a repetition, guys, that we talked about. So from the line KT, you can just consider maybe this is your x1, y1. At T, this is your x2, y2. So they we are simply adding, we are simply subtracting the values that you are given on the x and also on the y. So x2, you're just going to consider if this is 1, you're going to have 1 minus, it was supposed to be 1 minus the x value there, it's a minus 5, so it's 1 minus minus like this. So it's going to be a plus. So that's 1 plus 5 squared plus, you do the same thing on the y, that is the y2, which is 6, minus the y value on the other point, which is 1. So this is 6 minus 1 squared. So this is you and your calculator in the simplification. Actually, by just having this, it is actually enough to present your final answer. If you are given something of this nature, it is enough to present your final answer. This is what I'm trying to say. We can just have our calculator this way. This is the square root of, you're going to have to open a bracket. That's 1 plus 5 squared, or that is just a 6. All right. And this is plus this bracket, you're going to have 6 minus 1 squared, which is same as 5 squared. All right. Which is the square root of 61. So you can just have it with this presentation. Then you can also just write your answer there. So this is the length of line, which is measured in units. All right. We do not have something like centimeters there. We just work with what? With the normal units, just like units on the Cartesian plane. All right. If it was where we're talking about the actual length in centimeters or meters, we use the units that are in meters, but these are points on Cartesian plane. All right. Just consider them as what? As units, even area, square units like that. 1.2, determine the length of the line KT in the form, so the equation of line KP in the form of y is equal to mx plus c. All right, K to P. This is what we have. This is point K and this is P. So as we know, if you're calculating the equation, you are going to need these 2 points. All right, this is 1.2. So you're going to need the point K, which is minus 5, 1, and also the point P, which we are given as 7, minus 2. These 2 points are enough for us to have the equation of line KP. Why? Because we understand that if we are to write this equation in the form of y is equal to mx plus c, m is the gradient of the line that you can calculate from these 2 points. So m being the gradient, remember the change in y over the change in x concept. That's how we're going to have y2 minus y1. The y2, that is the y value of the second point, minus the y value of the first point, which is 1, over x2, which is the x value of the second point, minus the x value of the first point, which is a minus 5. So this is going to give us the gradient of the line, which you can also just simplify, direct. That is a fraction there. You're going to have minus 2 minus 1, all right, over 7. Minus, simply, that's a plus there, all right? That's a plus. You can just save it this way, which is fine, but that's a plus, which is minus 1 over 4. So that was going to be the gradient of the line that you are supposed to calculate its equation. So having the gradient of the line, therefore, you can just substitute y is equal to m, that is minus 1 over 4 x plus a c, where c is the y-intercept of the line. If there was the y-intercept that is properly given, of which the y-intercept there is b, and I do not have this point b, so there's nothing that I can take advantage of. So I have to substitute one of these points that I'm given, either point k or point p is up to you. So I'm just going to take the point k, given x and y. It means in place of y here, we are going to substitute a 1. So you substitute any given point, any given point in that nature. All right, so in place of x and y, you substitute that. So y there is 1 from point k, and the x value is minus 5. So this is going to be equal to minus 1 over 4. So that's minus 1 over 4 times x, which is minus 5 plus a c. So that is what you're going to have. So if you are to simplify, multiply this, you're going to get 5 over 4 plus c. Then you transpose the 5 over 4 to the other side of the equation so that it becomes a positive there. So if we are to transpose this, it's now a negative. It was a positive here, so it's going to be a negative. That's 1 minus 5 over 4 is equal to a c. That's just like that. Just like that. So this is your c, which is the y-intercept of the line. That is, we can now rewrite this equation. Therefore, our equation is going to be y is equal to mx plus c, where our mx plus c we wrote here as minus 1 over 4x plus a c, so that's plus minus 1 over 4 like this. So this is going to be minus 1 over 4, plus and minus, that's a negative. So that is our equation of the line. That is what you simply needed there. All right, so with this, we are asked to calculate the length of AB. All right, from A to B, you are going to need the point A and also point B. So what is it that we have? Remember, we calculated the equation of this line KP. So what we know about KP is that B lies there. All right, we have got the equation of this line. This is the one that we just calculated now. Y is equal to minus 1 over 4 x minus 1 over 4. That was the equation of the line. Remember that. Okay. So if you are to consider that, we can have the B, which is the y-intercept in that case. Remember, okay, let me just put it this way. Let me just have it this way so that you understand me. So there, as you can see, 4 marks. You've got a lot of things to consider, but not that much. So this is it. Let's say we to calculate the length of AB. So far, we have got the equation of KP, and on this line KP that we are given, its equation, B is the y-intercept there. So meaning to say we can have the coordinate of B. Remember, for the y-intercept, x is equal to 0 there. So if x is equal to 0, it means the y value there was going to be minus 1 over 4, which is the y-intercept. So this is the point that we are given here at B, which is 0 minus 1 over 4. So with the same concept, we are going to calculate the length of this line, which is a vertical line. considering the point A, that is also the y-intercept, but the y-intercept of the line TK or KT, this line, that we do not have its equation. If we were given the equation of this line, just like on this part, we are going to consider the y-intercept of that line, but we do not have the equation. We are not given. We never calculated this equation. So meaning to say, on this question, you were forced now to calculate the equation of KT. You are now forced to calculate its equation. What you just calculated from KT was the length. You never calculated its equation. So that is, we go back to our KT and calculate the equation of KT. All right, so we are going to determine the equation of KT, the line KT. So to have the equation of line KT, as usual, you're going to need the gradient of KT, which is from the change in y over the change in x concept, meaning to say that we are just going to substitute y2. Already we indicated our points before. So y2 there, that's 6 minus y1, which is 1 over x2 there, that's a 1 minus x1, which is minus 5. So it's 1 minus 5. So this is what you are going to have as the gradient of the line KT, right? And that was going to give us 5 over 6 if you use your calculator properly. So with the gradient, we are going to need the equation now. So remember the equation, we are going to consider y is equal to mx plus c. So from y is equal to mx plus c, y is equal to m, which is the gradient, 5 over 6x plus c, which is the y-intercept. Substituting any of the given points which we are given on this line that we have, we can just take any point, consider the point K, x and y. X is minus 5, where y is a 1. You're going to substitute y is 1 when x is a minus 5. So our x there is minus 5 plus c. So we substitute the point K, which is minus 5, 1, x and y value. So that is what we are going to have at the end. Is going to be, if you multiply, that was going to be minus 25 over 6. Minus 25 over 6 plus c. Transpose this to the other side, it becomes a positive. So 1 plus 25 over 6 was equal to a c. So that means c is the y-intercept, which is 31 over 6. That is meaning to say y is equal to, you can write your equation if you want, 5 over 6x plus 31 over 6. We do not worry about that. We just need this y-intercept, which is 31 over 6. So along the line that we are given, remember I said A is the y-intercept of this line that we have now, which we calculated its equation, 5 over 6x plus 31 over 6. All right. So with this y-intercept, which is 31 over 6, when x is equal to 0, meaning to say we have got the point A, which is 0, 31 over 6 like this. We have the point A. So you are going to need the equation of this line. After having the equation, you find the y-intercept when x is equal to 0. That's the y-intercept. So having the point A and the point B, now we can determine the length of the line. So in most cases, this is what is going to happen, because you have got the point A in this case, which is given as 0.16. That is 0.31 over 6, I mean, like this. This is a vertical line where these 2 points, they lie on the same line, and along this line we can see that x is a 0 there. So whenever you have this type of a question and you're asked to calculate the length of a line, instead of using the distance formula, you subtract the y value from the top minus the y value on the bottom. All right, that is the top value minus the bottom value, or the maximum value minus the minimum value, or that is the condition that you can have. The y value that you have, the bigger value that you have on top, minus the one that, as you consider, the y value is the increase going up. So you take the one that is on top minus the one that is below. So if this is y1 and this is y2, the distance between line A, B can be given as y1 minus y2, just like that. The y value at point A minus the y value at point B, as long this is a vertical line lying on the same line, which is a vertical line. That is what you're going to consider. If they were lying on a horizontal line, what was going to happen on the horizontal line? On a horizontal line, you shall be talking about x value. The x value at this point, don't worry about the y values. You consider both the y values will be the same, but the x values are the ones that are different. So the distance between line AB was going to be the bigger value, which is the maximum value, minus the lower value that you're given in terms of the x values. These values are the ones that are more bigger, which is the more positive compared to these values that is on the left side. So the length of AB was simply going to be x2 minus x1. The x value here minus the x value here, that's how you consider all horizontal lines and all vertical lines. You just take them as they are. You just subtract direct. So we saw that in these calculations, when it is like this, when you consider the y values, this is the y value on the top, the y value below. So it is going to be y2 minus y1. That is the y at point A minus the y value at point B. The y value at point A is 31 over 6. The y coordinate at point A minus the y value as it is with its sign you take as it is. This is minus 1 over 4. The y value at this point, you take it as it is. So minus, that was going to be a plus. So you're going to have 65 over 12, or as a decimal, that's 5,42 units. This is length of a line, remember. So this is how you calculate the length. As long you are working with a vertical line or a horizontal line. Vertical, you consider y values, horizontal, x values. It is different from a line like this. This is not horizontal, this one. This is just a normal straight line. Vertical, horizontal, know your lines, all right? This is a special type that you can use. But you could have used, if you do not understand this, you can still use your distance formula still. You are not limited. The distance formula still works. X2 minus x1, that is 0 minus 0 squared, plus the y values minus 1 over 4 minus the y value there, which is 31 over 6 squared. Still, you are going to have the same answer on the distance. But if you understand this, then please use it. It's going to be an advantage in your simplifications to know this idea. All right, so this is what we're given. And the last part of our question was to calculate the size of KTP, angle KTP. There's 6 marks for that. All right, there's a lot of consideration for these 6 marks. All right, let's see where our KTP is. So angle KTP on our diagram is the one that is given as angle theta. This one from K, T to P. This is the angle here that is given as angle theta. All right, so let us consider to say, how can we calculate our angle theta? There are so many things that we can put into consideration about our lines. It follows that I explained about the angle of inclination on the previous class. Make sure that you watch that video so that you understand this part or the idea that I'm going to explain on this part. I say that if a line is being drawn, a horizontal line, because you consider the x-axis as a horizontal line. So if we were to consider at point T and we were to draw a horizontal line at point T, using the same concept here that we have got on our x-axis, actually, we have got a horizontal line being drawn at what? At T. All right, just sorry for this, guys. All right, let's say a horizontal line was being drawn. It operates the same way as the x-axis because these two lines, they are parallel to each other. These two lines, they are parallel to each other. All right. So with this same consideration, or with this part that we have, that these two lines, they are going to be parallel. It means you can work these lines this side, or you can work your lines this side, because this line K to T, if you extend this line like this, the angle of inclination that you are going to use at this point here as beta, this angle here as beta, is the same angle of inclination that you're going to have here as what? As beta. Why? We are considering parallel lines, and we know that this angle and this angle, they are corresponding angles, the ones that form an F. So this angle beta inside of the shape and this angle, which is outside of the parallel lines, they are the same. They form an F in this case, all right, from our parallel line concept. So the angle beta and this one will be the same. So the angle of inclination here is the same as angle of inclination that we have and at this point. Same properties, meaning even if you're to consider this line here like this line like this, it's parallel. If you were to consider this line here, its angle of inclination, which is this angle here, considering to say you can have this angle of inclination, which is let's consider from this point here up to this point, because remember the angle of inclination is between the line and the right side of the x, which is the positive side of the x-axis. So this angle that we are seeing here is the same as this angle. Again, we are forming an F, which is the same alpha. This alpha here that we are seeing is the same as this alpha that we are seeing. So the same situation that you're going to have at this to say, okay, this is alpha, this is beta, then you can even calculate, it is the same. So the alpha that we are seeing here, the same alpha that we are seeing there. I explained that on the introduction of the angle of inclination. Make sure that you watch that video to have an understanding in full about that. All right, so this is what I'm going to do. With this, I can calculate beta because I know this beta is same as this beta that I'm having here, which is the angle of inclination from the corresponding angles concept. All right, so that's 1.4. So like I said, there's a lot that we need to consider there. 1.4. So beta, the angle of inclination, is the angle that is affected, or the angle that is going to be taken from the line KT. So this beta, we are going to take it from the line KT. Remember the concept about the angle of inclination, that if the line is of this nature, I said on that introduction that it has got a positive gradient. And when it has got a positive gradient, our M is simply arctan beta. So look now, look now, guys, you see this thing. Beta is equal to arctan of the gradient, which is our gradient of the line, that is the line KT, like this, okay? So beta, this angle of inclination, is an acute angle, all right? It is from a line that has got a positive gradient. How are we sure that? We talked about this on the introduction. The type of a line of this nature has got a positive gradient, but do not worry about that. If you do not want to know much, just calculate your gradient of KT. So we are not going to calculate the gradient of KT because we have got KT where we calculated its equation. Remember here, the equation of KT, we calculated this. So already the gradient is there, which is 5/6. When you calculated this, the gradient was 5/6. So the gradient of KT was 5/6. So meaning to say beta was simply going to be equal to arctan, the gradient of KT, which is 5/6. So that is our beta there. We have this beta. All right, so let's calculate our beta and see what we are going to have in this. If we are to have our answers to 2 decimal places, depending with the instruction that you'll be given on that part. All right, so let's just fix to 2 decimal place. All right, so that is beta, which is shift tan 5/6, like this. That is what you are going to have. That is going to be 39.81 degrees. So this is going to give us 39.81 degrees. If you fix this to 2 decimal places, that's our beta. So beta is this angle from this point up to this point here, which is 39, why are we even calculating this angle here? All right, so the question is, you are going to see that we could have just calculated the alpha because the alpha is covering here. Then we subtract from 180 to find this angle that we are having here. But you're going to need the beta now because this theta and this angle, let us just say we consider this as phi here in between here. Let's just call this phi. So you're going to see that theta, phi, and beta, they lie on this line, these three angles. So you need that part. So you need this beta. That's why you have to calculate this. Okay. So with the beta, we can also move on to the alpha. So alpha is the angle of inclination. This is our alpha here. Alpha is affected from the line, this line P here that we had from that point. All right, which is we can consider line PC. This is our same alpha here, the angle of inclination that we have. But as you can see, this line, it has got a negative gradient. Remember, I said all these lines, they've got negative gradient. So you are going through that process of finding the reference angle, then alpha is going to be 180 minus the reference angle, because the acute angle, which is this angle on this side, is our acute angle, which is the reference angle. So in this manner, our alpha is going to be equal to 180 degrees minus the reference angle. Remember, we talked about that. But we need the reference angle from where? From this line. Do we have the gradient of this line? TP. So from our calculations, we never had the gradient of line TP. We never had something like that. So you see now here we are forced to calculate this gradient of line TP. So lucky enough, we've got the point T and also the point P. The point T, remember, it was 1, 6, all right? The point T was 1, 6. And the point P was 7 minus 2. So we are going to need the gradient of line TP or PT, whatever way that you're going to have it. So this gradient of TP, the change in Y over the change in X, Y2 minus Y1, the Y value, minus the Y value on the first point over the X value of the second point, minus the X value of the first point. So this was going to give us the gradient of TP, which is minus 4 over 3. So like I said before that, truly this line, it has got a negative gradient. And if it has got a negative gradient, what you're going to need is to calculate the reference angle, which is arctan that you take when this is ignored. When you ignore a negative, you just take it as a positive 4 over 3. Ignore the negative that you're given. You obtain the reference angle that was going to give you something like 53.13 degrees. So this is our reference angle, which is this angle that we are seeing here as C1, this one here. This is the angle that we are talking about, this one. This is our reference angle that we are talking about here, which is 53.13 degrees. So definitely alpha, the angles on a straight line adding up to 180, we are supposed to subtract our reference angle from that to obtain alpha. If we are to consider our alpha, that was going to be 180 degrees minus the reference angle, which is 53.13 degrees. So theta is 180 degrees minus the reference angle. I talked about this. So that means our alpha at the end was going to be 126.87 degrees. So that is our alpha, which is the whole of this angle affecting our line, which is this angle is the same as this angle. Remember from that point that I was explaining. All right. So the question is that, what is the relationship that we are seeing between these two? What is the relationship that we are seeing? Okay, to calculate theta, we can consider to calculate this phi that I indicated here, which is fine, but it's gonna take us a lot of time. So not to consider that, or not to take a lot of time. Let's just consider this is a straight line. This is also a straight line. So what is that we know? The angle theta here is the same as this angle that we have here as theta on this side. Let me do this way from our vertically opposite angles. All right, remember, we have got the concept of vertical opposite angles. So it's the same as this theta here. Theta and these are vertically opposite angles. So if they are vertical opposite angles, how do you calculate this angle that is between this here angle? So like I said, I'm not going to consider this phi here, this phi that I indicated, because it's going to take us a lot of time. Let us just consider these two. This alpha minus this beta here, it gives us the theta, because we are seeing that theta plus beta gives us the whole of this alpha. This one, alpha, covers everything. All right. So we are saying theta plus this beta, theta plus this beta is equal to the whole of this alpha. As we need to calculate the theta. So theta, with the angle that we want, is going to be alpha minus beta. All right, just like that. So meaning to say, by subtracting this, so we're going to use the vertically opposite angles concept. All right, so that means our theta is going to be alpha 126.87 degrees minus the beta 39.81 degrees. So if you were going to subtract this, you were going to have the exact angle of theta, which is 87.06 degrees. There were so many ways that you could have calculated this. So I want you to consider this part of our introduction. I talked about that you can transfer the x-axis to the point which you are working with. It maintains the same properties as the x-axis as long you have a horizontal line. So meaning to say the angles of inclinations that we had here on this x-axis are the same as that one on this adjusted x-axis that we had to draw on that part. So these are the typical exam questions that you need to work with so that you prepare yourselves for the exams which are ahead of time.